Hello, Mr. Cummings here, and welcome to this video on introducing two-dimensional vectors. So in physics, we use two-dimensional vectors to describe motion that's occurring in two directions at the same time. So examples of one-dimensional motion and how they differ from two-dimensional. One-dimensional would be maybe a car traveling down the road, a straight section of road, an object just falling through the air. That would be one-dimensional motion. But as soon as we impart some sort of horizontal velocity on something moving through the air, say we throw a ball to our friend, that ball takes a parabolic path through the air. So it's moving up and down in the vertical direction, and it's moving to the right or left, depending on which way you throw it, in the horizontal direction. So it's moving in two directions simultaneously. So we'll start by looking at a position vector in two dimensions. We're going to use r with an arrow above it as a symbol for a two-dimensional vector, and r is composed of an x vector and a y vector. So similar to how you would plot a point if it had an x coordinate and a y coordinate, you just go over x and up y. You do the same thing with vectors, except once you have where that vector ends, you use a straight edge and you draw an arrow pointing from the origin to that vector, or to that point. And so our vector r is going to be this white line here, and then the x component vector is going to be a horizontal line that's pointing to the right, and our y vector, will be a red line, a vertical red line pointing up to that same point. So it's clear to see here from this picture that the horizontal vector, or the x vector, is 3 units long to the right, and the vertical vector is 5 units long upwards. But the r vector, it's not clear exactly how long that is. So if we notice here, this is a right triangle, so we can use tools like Pythagorean theorem to figure out what the resultant magnitude of that r vector is. So look at an actual example here. We'll say r1 has a x vector of 5 meters, and that's in the positive direction, and the y vector is 4 meters in the positive direction. So we're going to go 5 meters to the right on the coordinate plane, and then 4 meters up. We'll draw those two vectors, and our resultant will be the vector that connects from the origin out to where the y vector ended. And once again, if we want to figure out what the resultant vector r1 is in magnitude, we can just do the Pythagorean theorem, do 5 squared plus 4 squared, and take the square root of that. And we should get a vector that has a length of 6.4 meters. Now say we have some displacement that occurs in the x direction and the y direction. So our x position vector and our y position vector both change by some amount. All we need to do to show our new vector, what we're going to call r2, is we want to change each of the component vectors of r1. So for the x vector, we're going to reduce the magnitude of that vector by 1 unit, since we have a delta x of -1. So our vector will end, our x2 will end at 4, and then our y vector has a +2 delta, so we're going to add 2 units to our y vector, but making sure to start that new y vector where the new x vector ended. We always want to make sure that our y vector and our x vector are touching the tip of one vector to the tail of the other one. And our new r2 vector is going to be starting from the origin and pointing all the way out to where that y vector ends, that y2 vector ends. So while position can be a two-dimensional vector, a lot of times the two-dimensional vectors that we're dealing with are things like velocity or acceleration or force or momentum. So we'll take a look at a two-dimensional velocity vector. So instead of using our coordinate plane and the units here to describe how far something has gone, we're using the components of the vector to describe how fast it's going in each direction. So say we have some purple vector v that's at an angle. This vector is made up of a horizontal component that points to the right and a vertical component that points upwards, because the overall vector points up and to the right. So we can describe it with two independent vectors, the x and y, that each point in different directions. And what these symbolize is how fast the object is moving forward in the horizontal direction and how fast the object is moving upwards in the vertical direction. So just as we had position that can be represented with position vectors that are in 2 dimensions, we can also represent velocity. And it's typically more common that we see a velocity that has an x component and a y component to it. So here we have an example where we have a sailboat that's starting at the origin of this coordinate plane, and it's sailing with a velocity vector v equals 1 meter per second, comma 2 meters per second. What this tells us is that it's moving horizontally, so in the x direction, with a velocity of positive 1 meters every second. It's moving in the vertical direction with a velocity of positive 2 meters every second. So we want to draw a motion diagram showing the boat's overall position at each second of travel. We're going to do this by showing where the boat is going to be in the x direction, then in the vertical direction, and then we'll use those to figure out where it is out in the coordinate plane. So we see here that the vertical position and the horizontal position are all marked with their timestamps. So at 1 second, we see the boat has a horizontal position of 1 meter and a vertical position of 2 meters. So we can just treat these as coordinate pairs, and we can show the boat's position as a function of time. So we'll draw a white dot indicating where the boat is out in this coordinate plane at each timestamp. And if we wanted to, we could actually use our motion equations to write a motion equation for the horizontal position as a function of time and the vertical position as a function of time. And that would just be that the position is equal to the velocity in that direction times the time. And that's going to be it on this video going over 2-dimensional vectors, position and velocity vectors. Thanks for tuning in, and I look forward to learning with you next time.